Hello everyone, in this video I'm going to discuss how we obtain the by-part method. So given the situation, integrate u with respect to v is equals to u multiplied with v minus integrate v with respect to u. How to obtain this kind of situation? As we all know, the integration actually is antiderivative, or we can say the reverse process of differentiation. So meaning that it begins with the differentiation. So given the situation, differentiate the element uv with respect to x by using the product rule, and we will have v u prime where we have du dx plus u multiplied with v prime where we have dv dx. So as we mentioned earlier, the integration is the reverse process of differentiation. So now what we have to do is to integrate d dx for the function uv with respect to x. Same goes to the right hand side where we have integrate v du dx plus u dv dx with respect to x. Kindly split the situation and we will have u v equals to integrate v du dx with respect to x plus integrate u dv dx with respect to x. Simplify the situation and we will have uv equals to integrate v du plus integrate u dv. Kindly rearrange the situation and make sure this become the subject. So we will have integrate u dv equals to uv minus integrate v du. So this is how we obtain the by-part method. So here we have the question, integrate x multiplied with exponent x respect to x. So now, before we begin the integration, let's check whether the situation is suitable for direct method integration or not. So number one, is the situation belongs to constant? The answer is no. Number two, x to the power of n. No. Number three, ax plus b to the power of n. I believe it is not. Number four, exponential function. Yes, but in here we have two elements where we have polynomial and exponent. But for the situation number 4, only involve the exponential function. Number 5, is it a reciprocal function? No. Number 6, is it a trigo function? No. So meaning that in here, the direct methods does not match the situation given. So now only we are allowed to use the substitution method. So let u as a x. If we differentiate the situation, and we will have du dx. Kindly substitute the situation where we have integrate, the x will become u. And we have e to the power of u respect to u. Kindly refers to the situation. Notice that there is no changing in the format, but only the variable. So meaning that substitution method is not suitable for this case as well. Then only we are allowed to use the by-part method. So by referring to the situation where we have integrate u dv equals to uv minus integrate v du. By comparing the situation with this part, and we notice that we have to find the u and the dv. So by referring to ln, polynomial, exponent, and trigo, we can determine the variable for u and also the dv. So meaning that we have u. So in this case, the situation involved would be polynomial and the exponent. So polynomial come before the exponent. So x will be the u, and the rest, meaning that exponent x will be the dv. So kindly refers to the left. We have to differentiate the situation with respect to x, and we will have du dx. And then for the dv, we have to integrate the situation. So we will have v is equals to integrate the exponential function, meaning that kindly refers to direct method number 4. Copy the situation, differentiate the x, and we will have 1. And then do remember ln e. So meaning that v will be equals to exponential x. Next, what we have to do is to substitute the situation into the formula uv minus integrate v du. So where we have u is equals to x, followed by v where we have exponent x, minus integrate v, we have exponent x, and du is dx. So kindly focus on this part. Check, is the situation matched with the direct method? So in this case, yes, it is. Situation number 4. So now, integrate x exponent x with respect to x is equals to e multiplied with exponent x minus integrate exponent x, and we will have exponent x plus c. So here we are, and thanks for watching.